So we're going to look at some more proportional parts today. Imagine that. We've done a lot with proportions in this unit. We got special segments of similar triangles. When two triangles are similar, corresponding, I don't like using the A that's there, but I will, corresponding altitudes, angle bisectors, and medians are proportional to corresponding sides. Special segments, first set that we're going to look at are the altitudes. The altitudes in these figures are segment AD and FJ. Those are proportional to the length of the corresponding sides. So the corresponding sides are AB and FG, but it might have been AC and FH. Those also are corresponding sides, right? So this statement said that in this diagram, AD, the altitude, is to the other altitude, FJ, as AB, the red segment, is to FG, the red segment. So they use those two sides. But I was going to write for you, and I want you to realize that each one of the ones we're going to write down today actually goes in more, there's more than one proportion setup that you can do. Oh, I colored the wrong thing. I don't want that purple. What color did I make those? I made the altitudes blue. Oops. All right, so what I was going to point out is you could have done AD or AD is to FJ as AC. So say you had numbers over here instead of on these two sides, you could say as AC is to FH also, right? So there's more than one proportion that you can set up, depending on what you're given, if you know the altitudes. The next one is if two triangles are similar, the lengths of the corresponding angle bisectors are proportional to the corresponding sides. The angle bisectors in this picture are RT and LP. The statement they chose to make is that LP is to RT as LM is to RS, those two corresponding sides there. Okay. Now, could I do another proportion that would be true? Absolutely. I could say LP is to RT as LK is to RQ. I'm just not going to write all of them possible down, okay? Next, it says, if two triangles are similar, the lengths of the corresponding medians, this time I'm talking about the medians, are proportional to the lengths of the corresponding sides. The medians are CD and YZ. What a median is, again, is a segment. We've already talked about this in Chapter 5, or the end of last semester. They are segments that go from a vertex to the midpoint of the side opposite and cut, of course, that side in half. All right, and they said that those correspond, CD is to YZ as AB. Oh, they went all the way across here. So you can use any of the three sets of corresponding sides in your proportion. I don't know why. Are those double marked or single? They really should be double because these aren't the same length as those up there. Okay. All right, and that's just the ones I put in blue. You could, of course, do CD is to YZ as AC is to WY, or the other sides over there. All right, so let's see some examples. Name the kind of segment first. So we got to know how to name these segments. What are these things where the X and the 7 are? Are they angle bisectors, or medians, or altitudes? Yeah, those are tallness, right? Those altitudes. Okay, now we're going to set up a proportion in order to find the missing altitude. We've got x is an altitude and 7 is an altitude. So x is 7 as, okay, so I went altitude to altitude, and then I'm going to go as side to side. So as 10 is to 8. And I could have done the 10 and an 8 on the bottom if I'd wanted. I'm going to cross multiply using our cross product property of proportions. 8 times x would equal 7 times 10, which is 70. Then we're going to divide both sides by 8 and get x is whatever that is. 8.75, right? That's how we're going to use the altitude property. All right. The second one, what are these things? Where the 20 is and the x. Well, they cut those sides in two, so those are medians. They go to a midpoint. The medians, 20 and x, we can write in a proportion. 20 is to x as, well, what I've got to use, started with the 20, which is on that first figure, so I'll have to write the 36 first, is to 18. You can do your cross products again, or you need to. That'd be 36 times x equals 20 times 18, which is 360. We'll divide by 36 on both sides and get x is 10. Okay, on number 3, what is this thing? You see the little arcs there? Yep, that means it bisected the angles. So those are angle bisectors. All right, and I'm going to do the angle bisectors compared 9 to 6 equals, I'm going to go back to that first figure. I see a 12, and that would correspond to the x. Yes. Okay, I actually was about to bring that up. Okay, do you have your 9 across from your x in whatever you wrote? Then you're okay. This would be 9 times x equals 72. And now I'll finish this and then I'll explain what I was just talking to Bryce about. That'd be x is 8. He asked me, what if you had those flipped over? Or, here's another way to look at it that I think will help some of you. Couldn't I do 12 over 9 equals, and just look at it like a fraction, right, like that, and then look over here at this like a fraction, x over 6? Do I have the right stuff across from each other? And I do. So if that makes this work better for you, you can do that. I'm trying to follow the, I'm trying to follow the theorems, if you will, okay, instead of just giving you a shortcut. But I want you to see that, remember, I've told you over and over again that there are 4 ways to correctly write any proportion. So you can do whatever you see like that. You can say 12 over 9 equals x over 6. Is that how you had it, Bryce? Or 12 over x equals 9 over 6? Yeah, that's totally fine. So again, there's 4 correct ways to write it. All right, let's check out the 4th thing we're going to learn about today. So right now we learned that the sides are proportional if you have with the altitudes. The other 2 sides are proportional if you have the medians. And if you have angle bisectors, the angle bisectors are proportional to the other 2 sides. Or to 2 corresponding sides in the triangle. So this one says the triangle angle bisector theorem. The triangle angle bisector theorem has another special thing about an angle bisector. The angle bisector here is SU. And an angle bisector in a triangle separates the opposite side into 2 segments that are actually proportional. Proportional to the lengths of the other 2 sides. So what does that mean? Well, what it means is if you have an altitude angle bisector SU, it will cut the RT side into RU and UT. And RU and UT are in the same proportion. Notice I haven't got two triangles here. I only have one triangle. But I can work on this one triangle using this triangle angle bisector theorem because that piece X and the 20 are in the same proportion as 15 and 30, the other two sides. So here's how you can use this. So I'm going to say X is to, it says RU is to TU as RS is to TS, which would let us fill in X over 20 equals 15 over 30. Now, just like I said on the last problems, you could do what you see here as a fraction. You see 15 over X there? You can do 15 over X equals, and then go up here, 30 over 20. That works too. Notice I still have 30 and X across from each other, and we get 30X equals 300. And then we divide by 30, and we get X is 10. Either proportion here will give us the same cross products. Okay, that's all I'm pointing out. And hopefully you're paying attention because this is really not very hard. Especially these problems where you just have to find X and it's not real complicated. All right. Find the value of each variable. So here's some examples of the type of problems that we're going to be using the triangle angle bisector theorem. Okay, you got your angle bisector. What it did was it cut this side where the 10 is into two pieces that are proportional with the other two sides. So we're going to need to compare X and 13 and the 10 and what? I got one little step to do before I can get going on this problem. Yeah, I need to put 5 here because the whole thing's 15. Then if that's 10, then this piece would be 5. So I did 15 minus 10. Now I'm ready to go. And you can go straight up and down if you want. X over 10 equals 13 over 5. I think most of you would probably set them up like that. And maybe I'll just point out that that's red side on top, green side, green side. Okay, cross products are equal, so 5 times X equals 130. Divide by 5, and X is, what's 130 divided by 5? 26. Okay, the angle bisector again has split the side where the 11 and the 6 are, and the X are, and those are actually labeled already. So we can say X is to, there's 4 ways to write it correctly again. X is to 11. I don't know how you guys like to start off, or you can go this way. I think I'm going to go that way. I think you guys will see it better if I do this. X is to X plus 7 as 11 is to 17. So as long as I have the sides that are red in the same positions and the side pieces that are green in the same position, I'm all good. So I'm going to do 17 times X equals 11 times X plus 7. 11 times X plus 7 is 11X plus 77. We'll need to subtract 11X from both sides, which gives us 6 times X equals 77, and then divide by 6. The 3 repeats, doesn't it? Yeah, so we can just a bar on the 3. Okay, I hope I've not confused anyone. The theorem is saying X is to 11 as X plus 7 is to 17. But notice that I still have the same things across from one another. All right. Ooh, I got a little issue on the next one. So I'm going to give a hint out because when we do the when we get into the packet and we do more examples, I'm going to be asking you guys to help me set them up. What can I put right here? I got to label this because that's my piece compared to my piece. What can I write in that spot? So I'll give a hint. If n was 10, what would you do to fill this in? You would, if you knew this number was 10, you would subtract. You just said what I should do. I need to take away n from 46.8. 46, I shouldn't have written in red. I want to change the color, please. Sorry. 46.8 minus n needs to be labeled. So I'm going to do 46.8 minus n is to, now if you want to do do you want to do the vertical ones like this, write it so it's set up like a fraction kind of already on the picture? I hope you follow what I mean by that, right? This over this equals this over this. I'll do my n on top. I'll put my 36 on the bottom and my 42 on the bottom. Okay, now I need some calculator help, please. I'm going to multiply 42 times 46.8, 1965. Thank you. And then minus 42n equals 36n. All right, now I need to add 42n to both sides to get my n's on one side. So now I bring down my 1,965.6, and that equals 78n. All the numbers don't always come out beautiful. Okay, so when you divide it by 78, you get 25 point what? 2? All right, here's the value. Okay, everybody good? Now we're going to draw. I do not need them to be beautiful and perfect. If you're going to show me, oh, and this should have said, draw the requested special line in each triangle from, it should be from X, showing proper marks. Well, what they mean by proper marks is, we're just going to sketch this. We're not actually measuring. So if I'm going to draw an angle bisector from X, okay, I'm just going to make arc mark and an arc mark to show I mean the angle got bisected, okay? The median should go from X to the midpoint of the side across, so I'm going to show that that's the midpoint of the side with little slashes, and I'm just going to draw a segment from X to that point. What would you need to show if you're going to draw an altitude? A 90-degree angle, right? So you come from that top where X is and come straight down and then show that that was a right angle. Okay, so now we're on to the packet. This is just review of the types of segments we've discussed in the class. Mid-segment that meets the midpoint of both sides. We didn't do that today. Perpendicular bisector, altitude angle bisector, and median we did talk about. These are old ones. There's a picture of a median, really nice looking picture. What an angle bisector is like, and an altitude. You've already got this stuff filled in. When two triangles are similar, corresponding altitudes, angle bisectors, and medians are proportional to the corresponding sides. You have this whole big chart on your worksheet. I'm not going to go through that. We already discussed it. So let's get on to the problems. I want to see what you guys got out of doing the ISN. So in the figure, triangle ABC is said to be similar to XYZ. Triangle XYZ, the angle bisectors are shown. Since triangle ABC is similar to triangle XYZ, the measures of the angle bisectors are proportional to the measures of a pair of corresponding sides. So it just has to be a pair of corresponding sides. So in this diagram, how would you set up the proportion? All right, I'm going to call on a bunch of different people. All right, Darylyn, you want to go first? Okay, so you chose to start with the angle bisectors, which is totally fine. 10 over 8 equals 24 over x. Okay. Since you have 10 from the first triangle, 24 needs to be on top over x. That will work. It's not the only way to set it up, but it's perfectly good. So multiply across 10x equals 192. Divide by 10, and we get 19.2. All right, number 2. Find the kind of, I forgot to fill that big line in. Oh, what's this big line for? Well, what does the directions say? Name the kind of segment shown. So what are these things right here? Those are medians. Back? What were you doing? Okay, thank you. No problem. All right, so I'd like a volunteer to set up number 2. How will we set that one up? Takasha? Okay. Yep. Now, will you tell me, honey, would it have to be 12 over x or x over 12? Which would be consistent with what you started with? You went 12 over 14. Yes, ma'am. It has to be 12 over x. Otherwise, you're going to get it wrong. Now, and that would be because your proportion wouldn't be true. It wouldn't be comparing the same order. All right, cross products are equal. So 12 times x equals 14 times 12. Can anybody already know what the size of this thing's going to be? 168? Was that 168? And then divide by 12, and I bet you got 14. Okay, so how might we have looked at this logically? Do you see how these are both 12? Go ahead, Cadence. Yeah, if these are 12, 12, 12, this has to be 14, 14, 14. But that's not going to normally happen. Not too often are we going to see that. All right, number 3. Name the type of segments and give me a proportion. Now, your hand went up and then went down. All right, Bryce. What are they? What's the 40? Go ahead. What are they called? Altitudes. Good. All right. And now, what is your setup plan? Okay. Then that would be fine. Olivia? Okay. Can I, yeah, what? Oh, I wrote 12 instead of 14, didn't I? Well, that was doofus. That was a bonehead move, excuse me. Should be 14. I have no idea how I wrote a 12 there. I was talking about the 12s, I think, when I wrote it, and oh, geez, I blew that. Now, are we better? Okay, sorry about that. Didn't mean to mess anyone's head up, and nor did I mean to write the wrong answer. That was silly. All right, so we got 45x equals 42 times 30. And then we're going to divide by 45. And we should get 28. Is that the only way to set it up? Absolutely not. So if you wrote something different, as long as you're getting 45 and x across from each other and these numbers across from each other, it's okay. These can be totally upside down, etc. All right, number 4. What are the segments and set it up? I need a volunteer. Come on, you guys, you can do this. Or I will call on some. Okay, all right, Dariana. Go ahead. This is altitude. Yes, ma'am. I just want to get rid of this. Okay, 4/3. Okay, so I'm not sure exactly how she was even looking at it, but no matter what I do, that's correct. Meaning, I don't know, because how would I know if you meant this 4 and that 3, and then that 3 and that and X, or if you went this 4 over that 3 and then this over this. It gives you the same thing, but it's accurate. It's correctly done. So we got 4 times X equals 9. And then when you divide, you should be getting 2.25. Okay, now we're on back to the fourth topic that we did, which is the triangle angle bisector theorem. We had the side splitter theorem, which we didn't really call it that, but I do. Now we're doing triangle angle bisector theorem. An angle of bisector in a triangle separates the opposite side into segments that are proportional to the lengths of the other two sides. So I think you guys are ready to help me out with these too. So we got an angle bisector. It has chipped away at this side. It's split it into 2 pieces that are proportional with the other 2. It has to be set up a certain way, 4 different ways correctly though. So I just need 1. Can someone give me a setup, please? Cadence? 20, say that again, please. 20/28, okay? Yes, all right, that is a good proportion. If you like to look at it like this, here's a good way to write it as well. See what I'm thinking? That works. But I still have what Cadence said, and I've got 20 across from X. So I've got 20X. 25 is across from 28. Multiply that at 700. And then I divide by 20. And I get 35. All right, good job. Number 6. Someone set that one up for me. If I don't get a hand. Oh, I already called on people that are raising their hand. All right, Kenny. 15/A equals 9/3. I see that too. That's a very quick way to do that. 9A equals 45 then. Divide by 9, and A is 5. I forgot to write my answers in my little blanks. Okay, 7. Okay, there's a step to do before we set this up. Nathan? Okay, so I'm going to need to put what right? You wanted me to put what here? There, you got it. And then what would your setup be? That'll work. Perfect. Okay, that is correct. We first needed to write something on this piece. All right, and now we're going to cross multiply and divide. 100R. Now, when I said set up, this is what I want to see on your paper. Then I don't mind if you just go to the answer, because I know a lot of you are probably doing 110 times 60 divided by 100. You know, you might be doing that. That's okay with me. That's 6,600. And then if I divide by 100, I should be getting 66. Oh, I'm doing Christmas colors. Oh, well. All right, number 8. I hope we're feeling pretty good about this. I've got to do some filling in from the words. You got a lot of stuff here. These are altitudes, PT is an altitude, blah, blah, blah. and km is an altitude. KL is 28, so I'm going to start labeling this thing. KM is 18. PT is 15.75. And then we're asked to find PR, so I'll put an X on that. All right, now that I have that drawn onto my picture, it might be easier to make my setup of my problem. I've talked to quite a few of you, but I need some more people. Let's see. Oh, it doesn't matter. Chloe. Or, yeah, what the heck? Chloe Harmon. I got this Chloe Phillips the other day. That will work. Isn't it interesting, though? What I'm doing this for is possibly to have you realize that your classmate may set it up a different way than you do, but it's correct. Okay? If you have 18 across from your X, then you've set it up correctly. So we got 18X, 28 times 15.75. Did anybody do that yet? 441? Okay. And then dividing by 18, that's 24.5. Okay, so P to R, I don't know why I wrote RR. PR is 25 point, I'm sorry, I already messed up. 25 point what? 24.5. I transposed my numbers. Thanks. All right, you are the ones with the calculators. Number 9, I've got that these are UA and ZB are altitudes, and then UT is 8.5, so I'm going to just label my picture. UA is 6, Z to B 11.4, find ZY. Okay, set it up for me. Oh, I haven't got this side of the room. Robert. Some of you are ahead of me, aren't you? Well, then you put it right. You have things in a good proportion. So 6 times X, and I don't know, that's got to be something icky. 96.5? 9. Oh, beautiful. Okay, and then divide that by 6. Well, I'm going too slow for you guys. Jeez. 6, what was that? Oh, 16.15. I wouldn't have done that one in my head. Not at least for a little while. All right, the homework is what's next. You got some time to work on that. I'm going to return your quizzes to you. So if hopefully next time somebody listens to this, I actually have the quizzes finished. Anyway, do your assignment, because practice is the only way you get better at anything.